Hey Math 10Cs, today we're going to look at conversion within the metric system or systems internationale. So the next three lessons will involve the conversion of units within and between the metric system and the imperial system of measurement. This lesson we're going to convert within the metric system using three different ways of doing it. Our metric unit chart or number line. We're going to look at proportional reasoning, and we're going to look at unit analysis. So all three of those ways. Lesson 5 and 6, it tells you what we're going to be looking at there. So conversion of units in the imperial or the international system of measurement. So we're going to talk about metric system here. Metric unit charts given below. This will be on your formula sheet. It's also on the front cover of your workbook. So complete the following. Looking at this chart, 1 gigameter is how many meters? So here's meters. We have to go all the way to gigameters. We can see that 1 gigameter is 10 to the 9th. 10 to the 9th meters, or 1 with 9 zeros after it. Alright. So you can use scientific notation if you want, or in expanded form. That's the correct answer. Alright. 1 megameter is how many meters? Well, here's a megameter, 10 to the 6th, or a million meters. And 1 kilometer we know is 10 cubed, or 1,000 meters. So 1 centimeter is how many meters? Well, now we're going the other direction. A centimeter is 0.01 of a meter, right, or 10 to the negative 2. A millimeter is 10 to the negative 3, or 0.001 meters. Micrometer, 10 to the negative 6, or 0.000001. And a nanometer is 10 to the negative 9, or in standard form, written like that, many meters. Now, those are for meters. We do the same thing for liters or grams. All right, we're still going to use our base unit there. So 1 liter is how many milliliters? All right, 1 liter is 1,000 milliliters. Um, 1 milliliter would be how many liters then? 0.001. All right. We could look at milligrams and grams. So 1 gram is how many milligrams? We're looking at grams now. We're going to milligrams. So 1 gram is 1,000 milligrams. Or 1 milligram is how many grams? Going the other direction, 0.001. 1 milligram is 0.001 grams. 1 kilogram is how many grams? So again, we're going from kilograms to grams, so that's 1,000. And 1 gram is how many kilograms? Well, 0.001, the other direction. All right. So that's using that chart. Note the prefixes hecto and deca are not very often used nowadays. Okay. Next page. Method 1, using the metric number line to convert within the metric system. The biggest advantage the metric system has over other systems of measurement is that units are all related to each other by factors of 10. From the metric unit chart, we can create a metric unit number line for use in conversions. When converting between units, we need to know how many positions on the number line we have to move. Each movement of 1 position represents a power of 10, or 1 motion of the decimal, or 1 move of the decimal. So every power of 10 means 1 movement of the decimal. For example, to convert from kilometers to centimeters, we move the positions 5 positions to the right, or 5 decimals to the right. So 1 kilometer is 10 to the 5th, or 100,000 centimeters. convert from centimeters to kilometers, we move 5 positions to the left. So 1 centimeter is 10 to the negative 5, or 1 over 100,000 kilometers, or we could say 0.00001 kilometers. So using this number line, let's do the following conversions. Rate each answer as a power of 10, and then in standard notation. So 1 meter is how many centimeters? So you put your pencil on meters, which is right here, and we're going to centimeters. That's 2 units, or 2 moves to the right. So that'd be 10 squared, or 1 with 2 zeros, centimeters. If I want to do millimeters to meters, I go from millimeters right here to my base unit of meters. So I'm moving 3 that direction, so that's 10 to the negative 3, or that would be 0.001 meters. And if we're looking at liters to milliliters, so again, I would start here, and I'm going to go from liters to milliliters. That's 3 motions that way. So that's 10 cubed, or 1,000 milliliters. So example 2. Convert the following measures, 7.5 meters to centimeters. Well, let's just erase what we had here and use that chart again. I'm going to go 7.5 meters to centimeters. So I start at meters, and I want to go to centimeters. So that's 1, 2, this direction. So I'm going to move my decimal here 1, 2 spots that way, or multiplied by 10 squared. So that's 750 centimeters. All right. If I want to look at milligrams to kilograms, again, I start at milligrams and I go 1, 2, 3, 4, 5, 6 that direction to get to kilograms. So I could take this and multiply it by 10 to the negative 6, or I could take my decimal and move it 6 spots this way. 1, 2, 3, 4, 5, 6. So you get 0.07235 kilograms. And let's look at micrometers to nanometers. So we start at micrometers and we go to nanometers. So here's our micrometer. I'm going to go to nano, 1, 2, 3 units that direction. So I'm going to take this and multiply it by 10 cubed, or move my decimal 3 spots this way. So 325,000 nanometers. All right, lovely. You guys try example 3 on your own, see if you can do it, and then we'll start this up again and make sure you get it. So these would be the correct answers. 12 kilometers to millimeters, we'd move it 6 spots to the right. So 12 times 10 to the 6, or in scientific notation, that's going to be 1.2 times 10 to the 7th millimeters. Part B, 580 micrograms going to grams. You'd move that 6 spots to the left, and then you change that into scientific notation, making it 5.8 times 10 to the negative 4. And finally, 15,700 centiliters. You're moving that to megaliters. So you'd move that 8 spots to the left, so that's times 10 to the negative 8. And then correct scientific notation, 1.57 times 10 to the negative 4. All right. Let's look at method 2, using proportional reasoning to convert within the metric system. In mathematics, a proportion is a statement of equality. It means we need an equal sign between 2 ratios. All right. So the ratios have to have the same units. In order to use proportional reasoning, we need to know one of the following: a commonly known conversion, or a ratio given in the question. So as in previous math courses, set the ratio up in this form. A over B equals C over D. This is proportional reasoning. there's an equation involved, an equality between two ratios. There are a number of ways of setting out the work for proportional reasoning. Whichever method is used, it's essential that we keep a careful eye on the units. The units must be equivalent in each ratio. Alice, Jim, and what's that name? Rima were asked to convert 300 centimeters into meters. Part of their work is shown below. Each knew that 1 meter is 100 centimeters. So if you look at Alice's, 1 meter is 100 centimeters. Therefore, how many meters equals 300 centimeters? So if I want to solve this for meters, I'm going to multiply top and bottom on the left side by 3 to get an equivalent ratio. So I will get, what, 3 over 300. So 3 meters over 300 centimeters would be equivalent. So 300 centimeters is the same as 3 meters. That's one way to do it. However, like it says here, Alice's method is very difficult to use if the multiplier used is not a whole number. In other words, right here, we're able to multiply top and bottom by 3. We won't always have a nice, easy multiplier like 3. So Alice's method is difficult if we haven't got an easy multiplier. Jim's method, 1 meter over 100 centimeters, x meters over 300 centimeters. He went and cross-multiplied. 1 times 300 equals x times 100. Then he divided both sides by 100. And that's this equation right here. Notice the centimeters cancel out. So you've got 300 divided by 100 leaves us with 3, and the only unit we have left is meters. So x is 3 meters. All right. So 3 meters is the same as 300 centimeters. And Rima said 100 centimeters equals 300 centimeters if 1 meter equals how many meters? So again, Rima cross-multiplied. 100 times x equals 1 times 300. Then she divided both sides by 100. And we get this equation. We notice the centimeters should cancel out. And we're left with 300 times 1 divided by 100, which is 3. And the only unit left is meters. All right. So both Jim and Rima use cross-multiplication to solve the problem. Notice the centimeters always cancel out, leaving the only unit as meters. When the cross product calculation is performed, the units should cancel out where necessary, and the remaining unit left is the required unit, the one we're looking for. All right, we won't worry about this alternative approach. We'll try a few examples. A photograph of an African elephant has a scale of 1 centimeter represents 0.6 meters. So I'm given a conversion. So let's do that. 1 centimeter is the same as 0.6 meters. We're given that conversion right there. 1 centimeter represents 0.6 meters. The elephant's trunk in the photograph measures 3.5 centimeters. So I've got centimeters in my numerator up here, so I better have centimeters again. What's the actual length of the elephant's trunk? We don't know. X meters. All right. I've got that equation. I want to solve for x. I'm going to use cross multiplication. X times 1. So we've got 1 centimeter times x will equal, let me use cross multiplication here, 0.6 meters times 3.5 centimeters. 0.6 meters times 3.5 centimeters. All right. Now I divide both sides by 1 centimeter. And we find out that x is going to equal 0.6 times 3.5 divided by 1. And our units will cancel. We get rid of those centimeters. And I've only got meters left. So the unit we're left with is the one we want. So 0.6 times 3.5 gives us 2.1 meters. So the actual length of the elephant's trunk is 2.1 meters. Example 6. Reba followed a recipe for rice bean soup and used 175 milliliters of beans and 650 milliliters of rice. She realized she had not made enough soup and added another 70 milliliters of beans to the soup. To keep the ratio consistent, how much rice should she add? So we're given a situation where we've got 175 milliliters of beans and 650 milliliters of rice. Well, she added another 70 milliliters of beans. How many milliliters of rice should she add? So there's our question. Again, I want to now cross multiply. So x times 175 milliliters of beans should equal 650 times 70 milliliters. 650 milliliters of rice times 70 milliliters of beans. So if I want to solve for x, I'm going to divide both sides by 175 milliliters of beans. And we find out that x should equal, well, the beans are going to cancel out. How many milliliters of rice do we need to add? All right, so how many milliliters of rice do we need to add? We got to figure that out. 650 times 70 divided by 175. So 260 milliliters of rice. All right, the third method we need to look at is using unit or dimensional analysis to convert. So proportional reasoning is useful when only one conversion is necessary. If several changes of units are required, we want to do proportional reasoning several times. We call that unit analysis. All right. So unit analysis or dimensional analysis is another method of converting between different units. Unit analysis is commonly used in high school and higher level science classes and is particularly useful when many units are involved. If only one conversion is required, the basic setup is this approach. Required equals given times conversion, with units being placed properly in the numerator and denominator. Huge statement. Units placed appropriately in the numerator and denominator. If done correctly, the units left over will be the required unit in the answer. So consider the process of converting 75 millimeters to meters. Like proportional reasoning, a known conversion is used. 1 meter is 1,000 millimeters. When we multiply as shown, so what's required equals our given, 75 millimeters over 1. This is usually how we start. Our given over 1 times our conversion, and notice I've got millimeters in this numerator. I want to get rid of millimeters, so I put the millimeters in the denominator of my conversion, and I multiply so that when I multiply, my millimeters are gone. See, the millimeters cancel out. I'm left with 75 times 1 over 1 times 1,000, or 75 meters divided by 1,000. This gives me 0.075 meters. All right. So convert the following measures using unit analysis. 12 kilometers into meters. So we start with what we're given, 12 kilometers over 1. And now we multiply. All right, we're going to change kilometers to meters, and we know how many kilometers are in a meter. But what you want to do is make sure we have our kilometers in the denominator so that they can reduce and get rid of each other. So that means our meters must be in the numerator. So I know that 1 kilometer is 1,000 meters. And now I can multiply 12 times 1,000 divided by 1, so I get 12,000. And our units, kilometers, will cancel off. I'm left with meters, 12,000 meters. Perfect. So let's do the same thing over here. We start with 2,730 nanometers over 1. I'm going to convert that into meters, so I want to get rid of my nanometers. So if you go back and look at your conversion, we know that 1 nanometer, 1 meter is the same as 10 to the 9th nanometers. Again, if we're doing this properly, our nanometers now should cancel out. We're left with unit of meters. And now we just have to multiply. 2,730 times 1 divided by 1 times 10 to the 9th. So do that calculation, and we move our decimal from here 9 spots this direction. So we're going to have the answer of 0.1 1, 2, 3, 4, 5, 6, 7, 8, 9 meters. There you go. So unit analysis is particularly useful when multiple conversions are required. For example, to convert 2.4 kilometers into millimeters, you would first convert from kilometers to meters and then from meters to millimeters. So complete the unit analysis calculation started right here. So 2.4 kilometers over 1, that's how we start. We know that 1 kilometer is the same as 1,000 meters. We know that 1 meter is the same as 1,000 millimeters. So if I get rid of the units, a kilometer divided by a kilometer is gone, a meter divided by a meter is gone. The only unit I have left is a millimeter. Perfect. We were supposed to convert to millimeters, and we're going to do that. All right. So the only unit I've got left is millimeters. Now I take 2.4 and I multiply by 1,000. I multiply by another 1,000. So I get 2,400,000 millimeters. Convert 0.25 gigameters to megameters. All right. Gigameters to megameters. So we start with what we're given. 0.25 gigameters over 1. I want to convert that to megameters. Well, first let's convert gigameters to meters, because we've got that conversion. We've got that conversion on our chart. So I know that 1 gigameter is 10 to the 9th meters. And then let's convert meters into megameters. And on that conversion, we know that 1 megameter is 10 to the 6th meters. And so now if we look at the units we've got, I can get rid of my gigameters, I can get rid of my meters. The only unit I'm left with is megameters. So that's the one we want, megameters. Now I do my multiplication. 0.25 times 10 to the 9th times 1 over 1 times 1 times 10 to the 6th. So really the 10 to the 9th and 10 to the 6th reduced down to 10 to the 3rd. So 0.25 times 10 to the 3rd is 250 megameters. And finally, let's look at example 9. So he will need to know that 1 kilometer equals 1,000 meters. And he will need to know that there are 60 seconds in 1 minute. So those are the common conversions Zimmer will need to know. So let's complete the work. Starts off with 50 meters per second. That's what we're given. 50 meters in 1 second. Well, we know that 1 kilometer is 1,000 meters. And we know that 1 minute is 60 seconds. So let's finish this conversion. Meters will cancel out. Seconds will cancel out. We're left with kilometers per minute. That's what we wanted. Kilometers per minute. Now we can multiply. 50 times 1 times 60 divided by 1 times 1,000 times 1. So 50 times 60 is 3,000 divided by 1,000. We're left with 3 kilometers per minute. That's when unit analysis is the best, when we have to do multiple conversions. All right. So you guys have your assignment. Let's get after it. All right. Away you go.